Today's news is packed with fascinating developments across the space and astronomy world. We've got quite a lineup, starting with an update to an intriguing medical mystery from NASA's latest crew return that has everyone talking still. We'll dive into how artificial intelligence is being deployed to help predict dangerous solar eruptions and explore an ambitious new satellite constellation project from a former Google executive that could reshape space-based communications. We'll also look at some setbacks in Europe's space program, examine China's latest rocket design that's raising eyebrows due to its familiar appearance, and share an exciting breakthrough in our understanding of black holes in dwarf galaxies that's rewriting what we know about the early universe. Let's get started with an update. Questions are swirling around a mysterious health incident that occurred following the return of SpaceX's Crew 8 mission from the International Space Station last month. While the splashdown itself appeared to go smoothly off the Florida coast on October 25th, what happened next has captured attention across the space community. All 4 crew members, NASA astronauts Matthew Dominic, Michael Barrett, and Jeanette Epps, along with Russian cosmonaut Alexander Grabenkin, were taken to a Florida hospital for standard post-flight evaluation. While this is normal protocol, what wasn't normal was that one of the NASA astronauts had to remain hospitalized overnight as a precautionary measure. The agency has confirmed that the astronaut was released the following day and is doing well, but has declined to identify which crew member it was or provide details about the medical issue, citing privacy concerns. This level of medical privacy isn't unusual. NASA has long protected its astronauts' personal medical information. During a recent press conference, Crew 8 pilot Michael Barrett, who is also a medical doctor, addressed the situation, noting that there's still much to learn about how the human body responds to spaceflight. He explained that sometimes they encounter unexpected physiological responses, and this was one of those instances. Barrett assured that once their internal review processes are complete, NASA will share more information about what occurred. This incident is particularly notable given that Crew 8's mission lasted 235 days, significantly longer than the typical 6-month rotation on the International Space Station. While this was an extended stay, it's worth noting that it's still far short of the current record for continuous time in space, which stands at 437 days, set by cosmonaut Valery Polyakov on the Mir space station in the mid-1990s. In an exciting development for space weather research, the New Jersey Institute of Technology has secured a $5 million NASA grant to establish a cutting-edge research center that will harness the power of artificial intelligence to predict dangerous solar eruptions. This groundbreaking initiative, known as the AI-powered Solar Eruption Center of Excellence in Research and Education, represents a significant leap forward in our ability to forecast potentially destructive space weather events. Working in partnership with NASA, New York University, and IBM, the center will develop advanced AI and machine learning tools specifically designed to predict solar flares and coronal mass ejections at their onset. These violent solar outbursts, powered by free magnetic energy in the sun's atmosphere, can trigger geomagnetic storms that pose serious risks to our satellite technologies and power grids here on Earth. One of the center's most ambitious goals is to create a comprehensive data set of solar activity spanning multiple 11-year solar cycles. By analyzing this unprecedented collection of data using sophisticated AI tools, researchers hope to uncover previously hidden patterns that could reveal crucial warning signs before major solar eruptions occur. This is particularly important for tracking rare but powerful X-class solar flares, which have been challenging to study due to limited historical data. Beyond the pure research aspects, this initiative will also serve as an educational hub, offering opportunities for students at all levels to engage with cutting-edge space science. The center plans to establish summer boot camps, workshops, and various programs designed to inspire the next generation of space weather researchers, with a particular focus on expanding opportunities in STEM education. This innovative approach to solar research could revolutionize our ability to protect our increasingly technology-dependent society from the impacts of severe space weather events, marking a new chapter in our understanding of our nearest star and its sometimes volatile behavior. Next up, a fascinating development is emerging in the increasingly competitive satellite internet sector as Logo Space, a startup led by former Google executive Milo Medin, announces it has secured the financial backing needed to deploy an ambitious constellation of 1,000 satellites in low Earth orbit. While the specific financial details remain under wraps, this development marks another significant player entering the space-based internet arena. The company has set its sights even higher, having filed applications with the Federal Communications Commission for permission to operate nearly 4,000 satellites using advanced K, V, and E frequency bands. However, Medin emphasizes that their initial goal of global coverage can be achieved with just over 1,000 satellites spread across 2 orbital shells. What sets Logo Space apart from its competitors is its targeted focus on government and enterprise customers, rather than the consumer market. The company is taking a notably different approach from other satellite internet providers, choosing to leverage existing space industry partnerships instead of building everything in-house. This strategy could potentially offer a more efficient path to deployment compared to competitors who are pursuing vertical integration. The venture is particularly noteworthy for its emphasis on electronic warfare capabilities. The constellation is being designed with sophisticated features to minimize signal interference and protect against jamming, utilizing higher frequency spectrum and narrow beams. This focus on security and resilience could prove particularly attractive to government and defense clients who require highly secure and reliable communications. With a target launch date of 2027 for its first set of satellites, Logo Space joins an increasingly crowded field of satellite internet providers. However, their specialized focus on enterprise solutions and security-conscious design could help carve out a distinct niche in this rapidly evolving market. Europe's ambitious next-generation rocket program has hit another delay, with Arianespace announcing that the second flight of the Ariane 6 will now take place no earlier than mid-February 2025. This represents a significant shift from the original December timeline, marking another setback for Europe's efforts to maintain independent access to space. The delay comes after what was described as a largely successful debut flight in July, though that mission did experience a minor anomaly preventing the upper stage from performing its final deorbit burn. While engineers have identified and addressed this issue through a software update, Arianespace has not pointed to any single factor causing the latest schedule slip. The upcoming mission, which will carry the S03E202 reconnaissance satellite for the French military, will be the first Ariane 6 launch to be fully managed by Arianespace. The rocket's core and upper stages are still at their respective manufacturing facilities in France and Germany, awaiting shipment to the launch site in French Guiana. Despite this setback, Arianespace maintains that the rescheduling won't impact the timing of subsequent launches. The company has ambitious plans for the Ariane 6, targeting 6 launches in 2025. This latest delay, however, underscores the ongoing challenges Europe faces in establishing a reliable, independent launch capability to compete in the increasingly dynamic global space launch market. Now, today's China update. In a fascinating development from China's space sector, the latest design of their next-generation heavy-lift rocket, the Long March 9th, has been unveiled at the 15th China Air Show in Zhuhai, and the similarities to SpaceX's Starship are impossible to ignore. The Chinese rocket will come in at least 3 configurations, with one version being fully reusable, much like its American counterpart. Standing at an impressive 374 feet tall, the Long March 9th will be powered by 30 YF-215 engines using liquid oxygen and liquid methane, the same fuel combination that powers SpaceX's Raptor engines. Even the upper stage features similar control flaps to those seen on Starship, suggesting China's engineers have been taking careful notes from SpaceX's innovative design approach. The rocket's capabilities are equally ambitious, with plans to lift at least 150 tons to low Earth orbit, putting it in the same class as Starship. This powerful vehicle is being developed by China's state-owned Academy of Launch Vehicle Technology, with an eye toward future lunar missions and other deep space exploration efforts. However, there's one significant difference in the timeline. While SpaceX's Starship is already conducting test flights and aiming for operational status by 2025, China's Long March 9th isn't expected to take its maiden flight until 2033. This 9-year gap could prove significant in the increasingly competitive field of space launch technology, though it's worth noting that space development timelines often shift as projects progress. And of course, we couldn't let an episode go by without a black hole update. An exciting new cosmic census has revealed an unprecedented number of black holes lurking in some of the universe's smallest galaxies. Astronomers have discovered approximately 2,500 dwarf galaxies harboring actively feeding black holes at their centers, more than triple the previous count of around 500. This groundbreaking survey has also uncovered nearly 300 new candidates for intermediate mass black holes, dramatically expanding our catalog of these elusive cosmic objects from just 70 prior possible detections. These findings are transformative, allowing scientists to study these mysterious objects as populations rather than rare individual cases. The implications for our understanding of galaxy evolution are profound. Every large galaxy we observe appears to have a supermassive black hole at its heart, but the chicken or egg question of which came first, the galaxy or its black hole, has long puzzled astronomers. These newly discovered dwarf galaxies and their black holes may hold the key, as they represent something akin to cosmic time capsules, preserving conditions from the early universe. Using data from the Dark Energy Spectroscopic Instrument Survey, researchers found that about 2% of the studied dwarf galaxies showed signs of active black holes, 4 times higher than previous estimates. This suggests these cosmic giants are far more common in small galaxies than we thought, fundamentally changing our picture of how galaxies and black holes grow and evolve together. The survey likely represents just the beginning, with researchers describing it as merely the tip of the iceberg. With more data releases planned and increasingly sophisticated detection methods being developed, we may be on the cusp of an even greater revolution in our understanding of these cosmic behemoths and their role in shaping our universe. And that brings us to the end of today's fascinating journey through space and astronomy news. If you're hungry for more cosmic content, I've got great news for you. Head over to astronomydaily.io, where you can sign up for our free daily newsletter and stay up to date with our constantly updating newsfeed. You'll also find all our previous episodes there, perfect for catching up on any space news you might have missed. Don't forget to join our growing community across social media. You can find us as Astro Daily Pod on Facebook, X, YouTube, Tumblr, and TikTok, where we share even more space content and behind-the-scenes glimpses into our universe. This has been Anna, and thank you for exploring the cosmos with me today on Astronomy Daily. Until next time, keep looking up and wondering about the mysteries that await us in the vast expanse above.